All right, so today we're going to take a look at Unit 6, Day 3, Simplifying Rational Expressions. Okay, now you might remember from Day 2 notes that we already kind of talked about what a rational expression was. A rational expression is a fraction, so that is very important to note, where the numerator and or denominator is a polynomial. Okay, so what's a rational expression? It could be something like this: x plus 7 divided by 8x squared minus 59. Okay, so that is a nice example of a rational expression, right? It's just a fraction, where both parts, numerator and denominator, are some type of polynomial. Okay, so we did some of this yesterday. Okay, what does it mean to simplify a rational expression? Well, simplifying a rational expression means if you find the same part in the numerator and denominator, you can get rid of them. Okay? And so I don't really like the word part here. Okay? So another way to think about it is a factor. All right? Because as we're going to see today, right, you might need to factor first. And this is really the big thing we're adding from from yesterday to today. Okay? So if you see the same factor or the same part, right, in both the numerator and denominator, you can simplify those, you can cancel some things out. Okay? So let's get to it. All right. So let's take a look at example 1. Okay? So we did something similar to this in the day 2 notes, right? 5x squared divided by 30x to the 5th. Okay? So whenever we simplify, we want one of each. We want one reduced fraction, and we want to have just one of each variable. So let's start with the fraction part. We have 5 divided by 30. Now some of you might jump to the gun and say 6. Now you have to be careful though, right? Because this is not 30 divided by 5, it is 5 divided by 30, right? So this is going to be 1 divided by 6, okay? And so now we take a look at our x terms. We have x squared over x to the 5th, right? We are dividing these x's, and so we're going to go ahead and subtract our exponents. And so 5 minus 2 is 3. That's the easy part. But where do I have more x's? Well, I have more in the denominator, so those 3 x's are going to go in my denominator. And so now, what are we left with? We have a reduced fraction, and we have just one variable, and so we are done simplifying. Okay, so that's a very base example of what we're going to be talking about. All right, we did some stuff similar to this yesterday. Okay, let's do another one similar to what we did yesterday. All right, so let's jump down to example 3. Okay, let's start off with the two numbers, right? 7 over 35. Now, don't just shout out 5, right? You got to be careful. 7 divided by 35 is 1/5. 35 divided by 7, that would be 5. Okay? And now, we're going to take what's in the parentheses, things like x plus 2, right? That is an expression. And we're going to look to see if we can combine or cancel that out with something that is the exact same expression. Be careful. X plus 2 cannot cancel out with an x minus 2. Okay? You can't divide these and get -1 or get 1 or anything weird like that. If it's in a parentheses, you can only get rid of it with something that's exactly the same. Okay? Now, there's going to be one exception to this coming up here in example 2, which we'll get to. Alright? But for now, x plus 2 divided by itself, those two things are going to cancel out. Okay? So let's just cross those out. And so now what are we left with? X minus 5. Anything here match up with x minus 5? Yes? No? Maybe? Nope. I don't think so. So x minus 5 is going to come along for the ride. Okay? One more. x minus 2. Any other x minus 2's here, right? Anything remaining? Yes, no, maybe? Nope, I don't think so. And so we are going to get x minus 2. That is going to stay in the denominator, all right? And so what are we left with? One reduced fraction, 1x minus 5, 1x minus 2, and unfortunately, our x plus 2's got rid of each other. Okay, and so that is our final answer. All right, now, how do examples 1 and 3 differ from examples 2 and 4, right? Well, examples 2 and 4 contain expressions in the numerator and denominator that are not factored, right? Example 3 here, everything was beautifully factored. Example 1, everything's also factored, but there's really just not much here, okay? So, when we take a look at these two examples, the first thing we're going to have to do is check to see, can we factor? And then do what we did on examples 1 and 3 and look to cancel some things out, okay? So, let's take a look at example 4 first, okay? This is a more traditional example. This is what you're mainly going to be seeing in this section and the rest of the chapter. All right, so example 4, okay? Well, the first thing we're going to have to do is we're going to have to factor each part of this. Let's start off with the numerator, x squared minus 144. How can I factor x squared minus 144? Well, let's see, x squared, hey, isn't that a perfect square? 144, isn't that a perfect square? Right? So this becomes x plus 12 times x minus 12. Right? So we have to remember our methods of factoring. We've definitely mentioned this. You got to know how to factor in this chapter. Okay? All right, let's move on. Denominator, x squared minus 15x plus 36. How could I factor that? Well, that's just going to be a simple number puzzle, right? 36 is going to go on top. Negative 15 is going to go on bottom. Okay, so what are some numbers that multiply to 36? How about 12 and 3? And so, in this case, right, since they have to add up to negative 15, both of these have to be negative. So, I can go ahead and rewrite our denominator as x minus 12 times x minus 3. And now we have rewritten our problem down to factored form. And so now we can clearly see what is going to get simplified here, right? So I have an x minus 12 in my numerator. I have an x minus 12 in my denominator, right? Both of those have the same exponents. So those will get canceled. Okay, and what's left over here? X plus 12. There's no other x plus 12 left here, right? So x plus 12 is going to just stay in the numerator. And in our denominator, sorry, I'm looking for a color, there we go. X minus 3, any x minus 3's here? Nope. So that is just going to stay. Okay, now remember, you can think of each of these as staying in those parentheses, okay? Don't get any crazy ideas. Oh, I can cancel out the x's, and then 12 divided by negative 3 is negative 4. Okay, don't do it. All right, x plus 12 only cancels out with an x plus 12. X minus 3 only cancels out with an x minus 3. Okay, so this is our final answer. All right, so to what we've been doing, we're just adding the step of factoring first. Okay, all right, so now let's jump back up and take a look at example 3. Oh, excuse me, example 2. Sorry, we already did example 3. Counting's hard. Leave me alone. All right, so on to example 2 then. Okay. 2x minus 24 divided by 12 minus x. Okay, so let's start with the numerator here. 2x minus 24. How could we factor 2x minus 24? Can I do a number puzzle? No, don't need to. Do I have to group? No, there's only two terms. I group when there's four terms. Do I have to split the middle? No, I don't have to do that. Are these perfect squares? No, I don't have to do that. Okay? We're going to have to do the most basic form of factoring, right? And that is the good old GCF. Okay? So, 2x and 24 both have what in common? Well, I can take out a 2 from both of those. So if I divide each of those terms by 2, I will get 2 times the quantity x minus 12. Okay, and now you can take a look at x minus 12. Can I do anything with x minus 12? Nope. So we are done factoring the numerator. Okay, now let's move on to the denominator. 12 minus x. Is there a GCF there? I think there might be. Okay, now this one is a little bit tough to deal with. Okay, but think back to the past couple chapters. A general strategy we've always had is let's keep the x's positive, right? Whichever x has the biggest exponent, in this case x is to the first power, right? Let's keep this x positive. So what could I divide both of these by to keep x positive? Well, what if I divided both of those by -1? Right? So now, if I divided both of those by -1, what would that give me? Well, let's see here. 12 divided by -1 and -x divided by -1. Wouldn't that give me -12 plus x? Okay? Now, not only do we want to keep the x's positive, right? X is kind of an egomaniac. It likes to be out in front. Okay? So we can rewrite -12 plus x as, wait for it, x minus 12. Ooh. Ah. And so, what did we get for Christmas? We got an x minus 12. We got an x minus 12. Those things are going to cancel out. And what is 2 divided by -1? That is just -2. Okay? Wow. What a question. All right? So, this is where we got to be careful here. Okay? So, we had an x minus 12 in the numerator, right? In the denominator, we had 12 minus x. Well, whenever you have something like this where the x is negative, you can go ahead and divide it by -1, and that's going to flip the order around. And so this becomes -1 times x minus 12. And if you don't believe me, go ahead and distribute the -1 back in. You'll get a positive 12 and a negative x. Okay? And then the beauty of this, x minus 12's cancel. We get these nice numbers here. And our answer is just -2. Perfect. All right. Okay. So we can see a clear difference between what we did yesterday. Whoa, sorry about that. We can see a clear difference with what we did yesterday, right? Versus what we're doing today, where we have to factor and then do what we did in the beginning of the chapter. Okay? All right. So let's keep going. All right. So, example 5, x squared minus 64. Okay? So, first thing we're going to do, we're going to take x squared minus 64, and we're going to factor that. And hopefully, after seeing some of the previous examples, we can pick up on the fact that this is going to be a perfect square factoring, right? So, what's the square root of x squared? That's just x. What's the square root of 64? That is 8. So, we're going to have x plus 8. And we're going to have x minus 8. Okay. Now, the denominator here, this is a fun one. 3x squared plus 25x plus 8. How the heck are we going to factor that? Well, this is going to be a splitting the middle problem. And so, how do we do one of those? I'm going to work down here at the bottom, right? We start off with the number puzzle, where we take the first term and the last term, and we go ahead and multiply. 3 times 8 is 24. And then we take the middle term, the 25, and that's going to go on the bottom. So two numbers that multiply to 24 and add to 25, that's going to be 24 and 1. And so now we split the middle. So this is going to be 3x squared plus 24x plus 1x plus 8. And now I have 4 terms, right? We have split the middle, and so we're going to finish this off by grouping. So what do 3x squared and 24x have in common? Well, I can divide each of those by 3x, and if I do so, I will be left with x plus 8. 1x plus 8, what do those have in common? Well, nothing. And so our GCF is just a 1. And if I divide each of these terms by just a 1, we're going to be left with x plus 8. Right? Dividing by 1 doesn't do anything. Okay? And so what can I do next? X plus 8, x plus 8, I can go ahead and factor those out. And so we get x plus 8 times, and now what is left over? 3x plus 1. Okay? So, factor the numerator, check. Factor the denominator, check. Now, let's go ahead and see what we have in common. I have an x plus 8, and I have an x plus 8. Cancel, cancel. And so what's our final answer going to be here? We're going to have x minus 8 all over 3x plus 1. Okay. Excellent. All right. Let's keep going. All right, example 6. Okay, let's start off with just the numerator. 5x squared plus 10x. So let's go through my options. Difference of two squares, are those perfect squares right there? Nope. Number puzzle? Nope. Well, what else can I do? Split the middle? There's only 2 terms. What's the middle there? Can't do that. Can't really group. There's only 2 terms, right? So we're just going to go with the good old-fashioned GCF. Okay? 5x squared and 10x, I can divide each of those by 5x. And if I do so, what is going to be left over? We're going to have an x plus a 2. Okay? Now, denominator on example 6, 5x squared plus 9x minus 2. All right, so just like in example 5, this is going to be another splitting the middle problem. Okay, so I'm going to do my work down at the bottom here. We're going to start off, like any good splitting the middle problem, with the number puzzle. Okay, actually, before I do that, let me draw a line here just so we know we're looking at different examples. Okay, so number puzzle, right? I'm going to take the first term, 5, times the last term, negative 2. So that is going to be negative 10. And the bottom term is going to be the middle, which is just 9. So I need 2 numbers that multiply to negative 10, but add to positive 9. So how about positive 10 and negative 1? That'll do the trick. And so let's go ahead and split the middle. 5x squared plus 10x minus x minus 2. Okay, right? Now I have 1, 2, 3, 4 terms. So just like we did last time when we had 4 terms, we're going to go ahead and group the first two and group the last two. Okay, let's see, 5x squared plus 10x. What do those two terms have in common? Hey, wait a minute. Didn't we already take out a GCF for 5x squared plus 10x? Right? We already did that? Right? Huh. Ain't that a coinky dink? So, we know that we're going to take out a 5x, and we're going to be left with x plus 2. Okay? And now, negative x minus 2. Remember, keep your x's positive. So let's divide by a negative 1. And if we divide each of these terms by a negative 1, so negative x divided by negative 1 is going to get us a positive x. And then negative 2 divided by negative 1 is going to be a positive 2. Okay, and now each of my terms has an x plus 2, right? And so this is the step I did up just straight in the denominator last time. This time a little more efficient with my room here. Okay, let's take out an x plus 2. And so we're going to be left with 5x minus 1. Okay, and so that is going to be in our denominator, x plus 2 times 5x minus 1. And so, as always, what is going to cancel here? We have an x plus 2. We have an x plus 2. Those two things are gone. Okay? And what's my final answer going to be? Well, first of all, I'm just going to slide us over here real quick. And our answer is going to be 5x divided by 5x minus 1. Okay? But wait a minute. Can't we cancel out the 5x's? No. Okay? 5x minus 1, that quantity is in a parentheses. It can only cancel out with another 5x minus 1. Okay? So don't fall for the trap. Alright? Okay. So two very nice, challenging problems that show what we're going to be looking at here. Alright? Okay, now let's get to some trickster guys. So, example 7. Okay? So we're going to do what we've been doing, right? Let's see if we can go ahead and factor some stuff here. X plus 10. Anything factor? Nope. We get just x plus 10. Okay? Let's go to the denominator. 3x plus 10. 3 and 10. Anything I can factor out of 3 and 10? Nope. Okay? So, my answer is just x plus 10 over 3x plus 10. But wait a minute. Can't I cancel out the x's, right? And cancel out the 10s and just get 1/3, right? And so, like we've been doing with all of the other problems we've taken a look at, this is absolutely wrong. Okay? You cannot do that. X plus 10 will only cancel out with another x plus 10. 3x plus 10 will only cancel out with another 3x plus 10. I cannot overstate this enough. Alright, so here we cannot simplify this any further. So what we started with is our answer. Moving on. Okay, example 8, the ocho. We know what we're doing by now, right? Let's take a look at that. Their numerator, 6x plus 30. So what can we factor 6x plus 30 to? Well, we can take out a GCF of a 6, right? So that gives us, let's see here, 6 times x plus 5. Okay? Alright, now what about that there denominator? Okay? That kind of looks like the denominators on the past couple problems we've had. But this time around there's one major difference. All of these also have a GCF, right? This is going to make our lives so much easier. we're going to divide by 2, we're going to divide by 2, we're going to divide by 2. So this is going to become 2 times x squared minus 8x plus 15. And we turned this gaudy splitting the middle problem into a very, very nice and simple number puzzle problem. So, number puzzle, 15 on top, negative 8 on the bottom, two numbers that multiply to 15 and add up to negative 8. How about a negative 3 and a negative 5? And so we can rewrite our denominator as 2 times x minus 5 times x minus 3. Okay? So let's go ahead and do that. I'm going to zoom us out here a little bit. All right. So we had the numerator 6 times x plus 5. All over, we just factored the denominator, and we got 2 times x minus 5 times x minus 3. And let's see here. What's going to cancel out? 6 and the 2, right? That's going to go ahead and cancel out. We have the 6. We have the 2. 6 divided by 2 is just a 3. Okay, nothing exciting there. X plus 5 cancels out with x minus 5. Wait a minute. These two are not the exact same factors. These don't cancel out. X minus 3 doesn't cancel out with anything either. The only thing we canceled out was the 6 and the 2. What a waste. Well, not really. Okay, so lesson learned here. Okay, as long as you can cancel something out, doesn't matter how insignificant it may seem, you still simplified it. Okay, so just because none of the factors canceled out doesn't mean we wasted our time, right? We still got rid of a factor of 2. Okay, and so this magnificent beauty is our answer. Good job. All right, one more that we're going to take a look at here, okay? So, example 9, 2x squared minus 162, okay? So, first thing we should be noticing, and, hopefully you're picking up on this, a lot of these problems have it. It's got one of them there, GCF, okay? We can divide both of these by 2, and we are going to be left with x squared minus 81. X squared minus 81. Boy, that sure looks like some perfect squares in that there parentheses. You are right. We can rewrite this as 2 times x plus 9, x minus 9. Well, wouldn't you know? And now we can take our denominator, 9 minus x. And what can we do with 9 minus x? Well, we talked about this earlier, okay? This was way back in example 2, right? Want to keep your x's positive. So what could I do to 9 minus x? Well, what if we factored out a negative 1? So that would give me negative 1 times, well, what's 9 divided by negative 1? That's negative 9. What's negative x divided by negative 1? That's positive x. What is negative 9 plus x? Well, I don't really like the way that's written, so why not go ahead and flip these? And so this becomes negative 1 times x minus 9. Well, hot diggity dog. Now, what do we have here? We got an x minus 9. We got ourselves an x minus 9. I reckon those two cancel. Hee-haw. That's enough accent work. I apologize to every person in the entire South. And now we can take 2 divided by negative 1, right? So that is just going to be negative 2, right? And then we have x plus 9. It doesn't have a dancing partner. So we're just going to have negative 2 times x plus 9. Now, if you really feel like it, you can go ahead and distribute that, but there is nothing really compelling you to do so, okay? Also worth noting, right, everything in my denominator got canceled out. So why do I need a denominator, right? I don't. If it makes you feel better at night, you are more than welcome to say all of this is being divided by 1, okay? But you absolutely do not have to. Now, had everything in the numerator been canceled out, whoops, excuse me, wrong tool, right? Then we would have had to have put a 1 up here, because you can't have nothing in the numerator, right? Denominators aren't as important. Okay? All right, so that's all we got for today. Your homework, as always, is worksheet, in this case, I guess, worksheet 3, okay? And I will see y'all, cowboys and cowgals, later. Again, sorry to the entire South and the entire West.